Logs and indices. Logs type 4, changing the base. So up until this point, all of our log equations have had the bases being the same on the left and the right hand side. So in the next couple of questions that we're going to be looking at, what you're going to find is that the bases are not the same. So we have to have a way of dealing with this, and that's going to be using the rule change the base. So if we go to page 21, on the right hand side, we can see this rule down here in the bottom right hand corner, the very last rule on the page. And this is going to be our change the base rule. So let's have a look at that rule, and we're going to write it in words to explain what does it actually mean and how are we going to use it. So what you'll see here is that we have base B on the left and then base A on the right. So what this rule is telling us to do is that we're going to be changing the base B to base A. So in words, what this basically means is that if we have log of a number to some base and we want to change that base, then it's going to be log of that number to the new base over log of the old base to the new base. So in other words, the old base is the letter B and the new base is the letter A. So one thing to note is sometimes students are like, well, what base am I going to change and what will I change it to? So it is always easier to change the bigger base to the smaller base. And all this does is it avoids a fraction in your denominator. So let's have a look at an example. So here we're just going to focus on changing the base rather than having it as part of an equation. So I'm being told that I have to change to base 10. So what am I changing? Well, if I look at the question, I have log 100 to the base 2. So what that basically means is we're changing base 2 to base 10. So that means that if we look at the equation, 100 is going to be x, the old base is going to be 2, and A is the new base, is going to be 10. So that's going to be then log 100 to the base 2 is equal to log x, which is 100, to the base A, which is the new base, 10, over log B, which is the old base, to the new base A, which again is 10. Now, obviously, we can put all of this into our calculator, but just for this example, we're just looking at how do we use and apply the formula. Okay, so let's look at another one. So we're going to change to base 2. So in other words, again, old base is 16, so that's going to be our letter B. X is X. Our new base is going to be base 2, which is A. So in other words, I'm going from base 2 to base 16. So again, if we apply our formula, we have log x to the base A. So that's going to be log x. Our new base is 2 over log b to the base A. So old base is 16, new base is 2. And again, if I wanted to simplify that, I can, of course, take this one step further and apply my calculator to log 16 to the base 2, which I could have obviously done in the previous example. And if I put log 16 to the base 2 into my calculator, I will get the number 4. So just taking it one step further each time. Okay, so in reality, we're not going to get those kind of just change the base questions. We're going to have an equation to solve that's going to require us indirectly to change the base, such as this example here where we're asked to solve for x. So normally we'd look at this and go, oh great, single log on the left, single log on the right, therefore both numbers must be equal. But we have to be careful with that because here, this time, my bases are not the same. I can see on the left my base is 4 and on the right my base is 2. So that means I have to decide what I'm going to do with my bases. So I'm clearly going to have to change the base to make them the same, but I have to decide, am I going to change base 4 to base 2 or base 2 to base 4? And the reality is it doesn't matter. You can do either and you'll still get the answer right. But as I said at the start of this video, that it's easier to change the bigger base to the smaller base, just so we don't get a fraction on the denominator. So that means I'm going to change base 4 to the smaller base, base 2. So again, if I'm looking at my rule, well, I'm going to take the bigger base, which is base 4. So that means I'm only looking at the component that has base 4 in it. So that's log 3x plus 1 to the base 4. And I'm going to say, well, what's a, what's b, and what's x? So the old base is b, which is 4. The number x is going to be 3x plus 1. And my new base a is going to be base 2. So therefore, log x to the base a is going to be log 3x plus 1 to the new base, which is 2, over the old base 4 to the new base 2. So in other words, if I simplify that, that's log 3x plus 1 to the base 2. And if I type into my calculator log 4 to the base 2, I get the number 2. So now if I go back to the equation that I started with, instead of writing log 3x plus 1 over 4, I can now say, not over 4, sorry, to the base 4, I can now say that that's going to become log 3x plus 1 to the base 2 divided by 2. And that equals log x minus 1 to the base 2. So I'm going to multiply both sides across by 2, which gives me log 3x plus 1 to the base 2 equals 2 log x minus 1 to the base 2. And now I can see I have a log on the left and a log on the right, both to the same base this time. But I still have a number in front of my log, and I can't have a coefficient in front of my log. I need to make sure that before I equate any terms, that I raise that to the power. So again, if we go back to our log rules, that's the third rule down on page 21. So if I zoom in on that, if I have a coefficient q in front of my log, then that q becomes the power of the number. So that's going to be log 3x plus 1 to the base 2 equals log x minus 1 squared to the base 2. And now I can see I have a single log on the left, single log on the right, both to the same base, which means I can now equate. So the equal sign tells me the left equals the right, which implies then that if the bases are the same, 3x plus 1 must equal x minus 1 squared. So now we just have an algebraic equation to solve. So if I square out my brackets on the right-hand side there, I have x squared minus 2x plus 1. Bringing everything to the right-hand side there gives me x squared minus 2x minus 3x, which is minus 5x, and 1 minus 1, which is 0, and that must equal 0. So it's not a full quadratic, so I just have to take out my highest common factor, which is x, and that leaves me with x minus 5, and that means that x must equal 0, or x minus 5 must equal 0. And if x minus 5 equals 0, that means that x equals 5. But of course, this was a log equation, so I have to go back and I have to check my answers. Always checking your answers in log and surd equations. So if I go up to the top to what I originally started with, if I have x is 0, that gives me log of 0 plus 1 to the base 4, so log 1. But on the right-hand side, if I have x equals 0, well, that leaves me with log of minus 1 to the base 2. And I cannot have a negative log, which means I must discard x equals 0. That gives a negative log. And then if I check for x equals 5, well, on the left, if I put in 5, that gives me 5 times 3, which is 15, plus 1 is 16. So log 16 to the base 4 is fine. And on the right-hand side, if I put in 5, I get log 5 minus 1, which is log 4 to the base 2, which is also fine. So therefore, x equals 5 must be my solution. So in this example here, we're asked to solve for x. And this time we're given another piece of information that x has to be greater than minus 2. So again, if we look at the equation, we can see that clearly x has to be greater than minus 2, because if it was minus 2, then these brackets here would become 0. And we know that log of 0 is undefined. So we have to keep that in mind when we're solving. So if we look at our equation, we can see we have logs on the left and a number on the right. But this time again, the bases are different. So I'm going to have to use my change of base rule. And we're going to change our bigger base, 27, to our smaller base, 3. So if we write out our rule, so log x to the base b is equal to log x to the base a over log b to the base a. So again, if we're changing base 27, that's going to be our old base. So we're going to go log x plus 2 to the base 27. That's the one that we want to change. So b is 27, x is going to be x plus 2 in the formula, and a is our new base, which is base 3. So that's going to be log of x plus 2 to the base a, which is 3, over log of the old base, 27, to the new base, 3. And if we type log 27 to the base 3 into our calculator, we find that that value is 3. So now if we go back to our equation, instead of log x plus 2 to the base 27, we can now write log x plus 2 to the base 3 divided by 3 plus log x plus 2 to the base 3 equals 4. I can't apply my log rules just yet because I have this divided by 3. So I'm going to multiply across every term by 3 to get rid of the fraction. So that gives me log x plus 2 to the base 3 plus 3 log x plus 2 to the base 3 equals 3 times 4, which is 12. And what's interesting about this one is that if we look very carefully, these are identical terms. So I have log x plus 2 to the base 3, and then I have 3 log x plus 2 to the base 3. So essentially we have 4 of the same terms there. So I can write that as 4 log x plus 2 to the base 3 equals 12. If I divide across by 4 then, I have log x plus 2 to the base 3 equals 3. And now I have a single log on the left and a number on the right. So if I look at my log rules, I'm going to change to index form here. So this rule here on the top of page 21. So therefore we have a, we have y, and we have x. So therefore we have a to the x is equal to y from our log y to the base a equals x rule. So therefore that's going to be 3 to the power of 3 is equal to x plus 2. So in other words, 27 equals x plus 2. So subtracting 2 from both sides gives me x equals 25. And again, we can go back and check, but we have only one answer, so that is our value. So if we go to our sheet, there are log questions on it, and you're going to do question 1 to question 26. No, sorry, not 1 to 26, sorry, 21 to 26. That would have been a lot of questions.